Hey guys, I'm live. How you guys doing? I'm out on my walk today. I want to do a video that's different than I've ever done, but similar but different. I want to explain calculus, single variable calculus in a nutshell. I think calculus is like the barrier between higher math and basic math. Once you reach calculus, if you get through it and don't get psyched out or don't get a barrier or don't get stuck or stopped, you can go to higher math very not too difficultly. But if you don't get past calculus or you get stuck there, you can't reach higher math. So let's just see if we can explain calculus to you guys. Okay. All right. Now, a function is a relationship between two variables where the independent variable is x. That's a horizontal line. That means it could be anything. The dependent variable is y. That's the vertical axis, and that depends on x. So if I say y equals x, then for whatever value of x, y is that. But x can be anything, but y depends on x. So that x is independent variable and y is dependent variable. And then there's such a thing as slope. Slope is how whether something is raising up or raising down or flat. If something it's called rise over run. The amount of increase upward divided by the amount of increase right to left gives you whether it's going up or down, or level, which is flat, horizontal. For instance, if rise over run is 3/4, then that means that the slope is up. It means it, and if rise over run is 0/4, then the slope is 0, because that would be flat. It didn't rise at all. But if rise over run is -3/4, then that means that the line slopes downward because the slope is negative. So the line sloped downward because you had a negative rise, which is a fall. So that meant the line goes down. Okay, that's what slope is, and that's what functions are. Now, calculus deals with the differential. There's two kinds of calculus. There's differential calculus and integral calculus. I'm going to talk about differential calculus first. It's the most fundamental and it's the hardest, I think, really conceptually at least. Differential calculus is basically deals with the rate of change of a function with respect to the independent variable. So in other words, if you have a straight line, the rate of change is constant. It's just whatever the slope of the line is. Slope is rate of change. If the slope is positive, it means it's changing, getting bigger. If slope is negative, it means it's getting smaller. And if slope is 0, it means it's staying the same. So for lines, the slope is constant because the line doesn't go up. The line is just straight. But for functions that aren't lines, and if you want to know the rate of change at any given time, the rate of change becomes a variable. If it's not a straight line, especially, and whatever that rate of change is at any given value of the independent variable, that's called the derivative, the first derivative of that function. The first derivative of a function is the function that says how fast, how much is the function changing, and in what direction at any given value of the independent variable. So, if I have a function and I want to know what the first derivative at the point of 5 is, x equals 5. If x is horizontal, then that would mean that how fast is that function going up or down or staying the same when x is equal to 5? It's a variable it's a function that is the instantaneous rate of change of the first function. Now, let's get some understanding of this deeper a little bit. I'm going to give you guys an example of this. So today's the winter solstice, okay? That means the length of days, the length of a day could be an independent variable, and time is length of day is the dependent variable and time is the independent variable. At any given time, how long is the day? The winter solstice was today at 7:03 a.m. So think of a U shape, like a parabola. Y equals x squared is an example of a parabola, like a ditch, or maybe a valley, or a U shape. Well, let's say it's at the Z. Let's say that the winter solstice is x equals 0. So that means that the parabola is is like a big U. When x is less than 0, the U is going down, because it starts at negative infinity. If x equals negative infinity, the U is infinity. And then as x gets closer to 0 from negative infinity, the slope of the function starts to level off more towards 0. It's even though it's still negative, it starts to be negative less and less. And then when x is positive or greater than 0, in our case, that this x would be time, but let's say we're the parabola y equals x squared. When x is greater than 0, the parabola is going upward, so the slope is positive. Therefore, the derivative is positive. Because the slope is curving upward. As x goes to infinity, the f of x, which is y, also goes upward toward infinity. But at the magic point, which if you use y equals x squared of the origin at x equals 0, then you find that the slope is 0, because the tangent to the curve at x equals 0 would be horizontal, which means the function is going neither up or down, which means the first derivative would be 0 at x equals 0. And let me explain this in terms of the days of the winter solstice today. Okay, so the winter solstice was at 7:03 today. That means that at 7:03, the day was as short as it gets all year. So how fast is the day, the length of the day, changing at 7:03 this morning? The answer is 0, because it reached a turning point, a turnaround. It went as low as it can go, and then started going higher. So at the moment at 7:03, when it got to its lowest point, the slope was 0, because it wasn't changing up or down. It wasn't getting bigger and it wasn't getting smaller, because by definition it was at its smallest rate. But at 7:02, the days were getting shorter still, but just by a little bit, like the U on the curve. Like it was just getting a little. It was getting shorter, but not by very much. And then at 7:03, the days were as short as they can go. So therefore, the first derivative of the function, how long the length of the day, was 0 at 7:03. At 7:03, the days weren't getting bigger and the days weren't getting smaller. Or the days weren't getting longer and the days weren't getting shorter. So that meant the function wasn't changing. The length of the days wasn't changing. So therefore, the length of the rate of change of the length of days was 0, which means the first derivative of the function, which is the how long the day is with respect to time, was 0 at 7:03 this morning. And then at 7:04, the day started getting longer again. So the derivative, the function, the length of the days was actually positive, meaning it was getting bigger, longer days, but not by very much. And so that U explains that as the U goes down toward, as we approach 703, the days are getting shorter, but not by very much. And then at 703, the day, the rate of the length of the days wasn't changing. It was constant just for a split second, and then as it goes at 704, the days were getting longer again, but not by very much. And the way to say that in terminology is that the derivative of the function if x is time and y equals the length of the day of the year, length of the day, then at any time before 703, the first derivative of the function L, length of day, was negative. At 703, the first derivative of the function L of t, length of day with respect to time, was 0. And then at 704 and onward, the derivative of the function L of t was greater than 0. And let's give an example of this in actual math terms. Let's say that our function is a parabola, which is a U shape. Let's say the equation of this we use is y equals x squared. So x is the horizontal, y is vertical. Y equals x squared is a U shape that contains the point 0, 0, which means it contains the origin. Now, the first rule of calculus, one of the first rules is, it's not the fundamental theorem, but it's one of the first rules, is called, it's just the derivative of a monomial is such as y equals x squared. That's a monomial. You take the value of the exponent, which in this case is 2, because x squared is x to the second power, multiply it by the coefficient of the x, which in this case is 1, because you only have x, not 2x, 3x, etc. Multiply those two together and make that the coefficient of the derivative, and then subtract the value of the power of the monomial, which in this case is 2, by 1. So therefore, if y equals x squared, y prime, or dy dx, or which is the derivative of y, is 2 times 1, which is 2, times x to the 2 minus 1, which is x, because x to the 2 minus 1 is 1, and x to the 1 is x. So the derivative y prime means the derivative, or the same as saying dy dx. If y equals x squared, then y prime equals 2x. Okay, that means dy dx is 2x, or y prime is 2x. And at x equals 0, y prime is, since y prime is 2x, at x equals 0, y prime is 0. Therefore, the function is the derivative of the function at x equals 0 is 0. Therefore, at x equals 0, the function is not changing. It's not getting less or great or more. It's just flat, just constant at x equals 0. The derivative y prime of x is 0, because the line is horizontal as it goes from going down to going up, and point in the middle at 0. It's the function has no rate of change. It's not changing, and therefore the first derivative of y equals x squared at x equals 0 is 0. The slope is 0, which rise of 1 is 0, and get my head straight here, and that is let me think here. Is this right here? That's because Yes, that's because y prime is 2x, and at x equals 0, 2x is 0. And then now for negative x, if x is negative, y prime is 2x. So if x is negative, such as negative 2, then y prime would be negative 4, which means that at x equals 2, the function y equals x squared is changing in the rate of negative 2. So that means it's getting less. And then at x equals positive 2, the first derivative of y equals x squared is y equals 2x. And y equals 2, if x equals 2, y equals 2x is 4. So at x equals 2, the derivative of the function y equals x squared is 2. I mean, it's 4, which is positive. So you have at x equals minus 2, function is the derivative is minus 4. And then at x equals 0, the derivative of the function is 0. And then at x equals 2, positive 2, the derivative of the function is positive 4. So that is just a basic introduction to calculus. Calculus is just taking a function and taking another function called the derivative, which is the rate of change of the original function with respect to time, and that's the first derivative. An integral is an antiderivative, and that's where you're given the derivative, and you want to find the function, the original function. So the question isn't what is the derivative of the function, but what function has this function as its derivative, and that's called integral calculus, or integral is just another word for antiderivative. So if you got through this, you understand the gist of calculus. And if you understand this, you could just open up a calculus book and start reading, and just a single variable calculus book to start. And if you can do that, you've just opened a doorway to higher math, which is what a lot of engineering and all kinds of science is based on. Love you guys. Peace, love, and rock and roll.